Hi and welcome to today's video. Over the last few weeks I've been working with a guy called Ian McRae who contacted us through the comments of another video, and what Ian wanted to know was, is there a way you could mount a different extruder and an E3D type hot end to the eBay Prusa printer. Ian had already kind of like started the process of modifying the y-axis of his printer, and he wanted to know if we could take it any further. He searched Thingiverse quite a lot and couldn't find anything he could use, so what I did was I fired up Fusion 360, designed a bracket, fitted it to my printer, got it working, and I've shared the design on Thingiverse. So this video, what I want to do is I want to show you the entire process of how I did that. A lot of people might think it's quite a complicated process. What I'm going to try and do today is show how simple it is. All you need to do is gather some information from your printer, design something in 3D. It doesn't really matter what it looks like as long as it's fit for purpose, and print it out and give it a shot. So first things first, I'll take you through what you need to know about your printer. So we'll just cut to the printer and we'll go from there. So here we are at the printer, and as you can see I've already stripped off the extruder, the hot end, the metal bracket and everything that came with it. So this is our X carriage. It's got two holes in, and I'm going to show you the information we need. So if we just zoom in a little, because this is what we're going to be talking about. Right, hopefully the camera will not wiggle around too much. And what we need to do is we need to know the distance between these two holes. Now this ruler, I chose this ruler because it's white on black, and I don't know if you can see. Can I zoom that in any further? There you go. So those two holes are approximately 30 millimeters apart. The tie wraps sit proud of the bracket, so we need to know the distance between the tie wraps, and the distance between the tie wraps is more than 40, so if we work on something around 40 that should be fine, and that's probably all we need to know. We know that these are M3, we know they've got a nut captured in them through the back, so what we'll do is we'll move over to the CAD screen and hopefully we'll design something that's going to fit on here and bolt to there. So here we are in Fusion 360, and this, as you can see, is the finished bracket, but I am going to take you through the entire process. So basically, if I turn it around, as you can see, we have something here which is a piece to mount the stepper motor to. If I turn it around that way, we have a mount there for the E3D, and we have two holes here which are recessed because obviously we want the heads to be quite flat. On the back it's very flat, and we have two hexagon shapes here just to hold the nuts for the clamp for the E3D. We remember that on the X carriage for the printer there is already two nuts captured in the back for these two mounting screws here. So I don't know if you're familiar with Fusion 360. If not, I'll take you a quick run through. The top of the screen here is telling us that there's an update. I'll just get rid of that. There we go. Now the top of the screen is all of your commands. So you've got sketch, create, modify. They're the only ones we're going to be interested in. We'll do a little bit of assemble, but we're not really interested in that. Down the left hand side of the screen is everything that we've assembled so far. So if I expand component and then sketches, you know, we don't need to see that. And across the bottom of the screen, this is the most important part. This is the timeline of what we've created. So what I'm going to do is I'm going to drag this back to the beginning, and this is where we start from. So you start from a completely empty screen, and what you need to do first is you need to create a sketch. So if I turn that sketch on, you can see it's a very, very complicated sketch. It's a rectangle, and if I right click here and edit that sketch, you can see that we're using 40 millimeters wide because that's the measurement we took from the printer between the tie wraps, 40 millimeters, and we're using 62 high. Now this 62 high started off as just any nominal number. It kind of changed as the design grew, but it ended up 62 anyway. So if I stop that sketch and we move to the next stage, we extruded that using the create extrude. I'll turn that sketch off, and we extruded that. How thick did we do it? I think it was 4 millimeters, there we go. And that is our base. So basically what's going to happen now is this back face here is going to sit against the X carriage, and this front face here is going to be where we build everything we need. 4 thick's quite good. You print it out about 35% filled. It's quite stiff and solid, so it's a good base. So the next sketch we created, I'll just switch that one on, was a rectangle like this. Now this rectangle is the rectangle that's going to come straight out of the screen, and it's going to be where you eventually mount the stepper motor to. So I wanted it to be quite strong, so again I made it 4mm thick. I made it 25 back from this right hand edge. That started off as a nominal number and it ended up 25. You can type in any number there you like, because as the process goes on you will modify it. And 44 seemed a good size to fit the stepper motor in. So we move to the next stage. Oh sorry, I've got to stop the sketch. We move to the next stage. I'll turn that sketch off. And we extruded that by how big? By 44 as well. So it's a square. It's a 4 thick square. And that's the second stage. Now, if you look at that, and if you were to put some holes in here, you think to yourself, it's not going to be very strong to hold the stepper motor. So what I did was, the next sketch, I sketched on, turn it around, on this surface here, and all I did was I just made a triangle which went down to the edge. That's all I did. And then I extruded that. I think that was 4 thick, or it may have only been 3 thick, because it's just there to support the stepper motor. I'll turn that sketch off. Just there to support the stepper motor. And I did exactly the same on this face. So now it's starting to look more like a conventional stepper motor bracket with these filleted sections in here, just to give it a bit of strength after it's printed out. So it's starting to look like something now. So then we moved on to the next sketch, which was a rectangle across the bottom, because obviously we need somewhere to mount our E3D, and you know we're just going to start off with a block. So I extruded that block. There we go. I extruded that up, and that ended up being 15mm. Now these numbers all become apparent when you take a look at whatever extruder you're using, because you need to line it up with the filament hole. So these are all to do with, I believe it's a left model of the Mark8 all metal extruder. You get them off eBay, they're very cheap. I didn't think it was going to be any good, to be honest, but it turned out to be a pretty good extruder. So this is all to do with that extruder. If you've got a different extruder, you just need to take some measurements of the extruder and then adjust the thickness of this block to where your extruder hole is going to be. So the next phase we did was just a typical extrude, and all I did was, I don't know if you saw that, I'll just undo it. I'll just undo it, there we go. So if we look at it from this edge, what you can do in Fusion 360 is you can just click a face and then cut it out. So that's all I did there, click that face and cut that out, just to make that look a little bit better. It's not necessary, you don't really need to do that, but it saves material and therefore it saves printing time. So the next sketch was, what was that one? Right, this one was a bit strange. Now I'll go into this sketch and try and explain it a little bit. This 4mm here is the distance between, what was that, 4mm again? It was the distance between the front face. Oh yes, that's right. There's a thick plate on the back of the extruder. It's 4mm thick. So that's the distance of that. So that was just to put that in. It's not for anything. It's literally just so that we can measure it. If I click top, it'll go straight again. Now this 6.5mm here was the distance from the edge of that plate on the extruder to the center of the extruder, of the filament guide hole, or the extruder hole, whatever you want to call it. So then what we could do is we could go 6.5, and then we had the center line of where the E3D mount was going to be. So we drew in the E3D mount and we used a revolve command. Where is it? There it is. So I'll just turn that sketch off. So as you can see, the only thing I selected for the revolve command was the actual profile of the E3D. The other stuff was just in there, kind of like for me to use as construction. You know, I just measured it off the extruder, drew it in, and then didn't use it in the feature. So that's where half of the E3D is going to mount. That's half of the clamp, basically. Now we move to the next sketch and turn that one on. This one is literally just the mounting holes and the large hole to mount the to allow the stepper motor to poke through. So what I did was, because this was a 44 square, I just set it up with this square detail here, and these crossed lines and these lines here all just refer to that being a square and that being in the center of another square, so that I didn't have to do too much to it, so that if I changed the size of the original square, everything would stay in the center. And then I extruded that and cut the holes in. So that is now the mount for, I'll just change its position a little. I think I've got to hold control, that's it. That's now the mount for the stepper motor finished. And as you can see, these fillets don't look very big, but they are plenty strong enough. So the next phase, whoops, is going to be some more holes, I believe. Now these holes, let's just move it around. This sketch has got a pretty big rectangle on the bottom. Now if I edit that sketch, this rectangle was to tell me exactly how far down the E3D hot end is going to be to the nozzle, kinda. So I'll put that in as 63mm. It's just literally letting me know where the bed is going to be in relationship to this mount. And these two holes are 30 apart, like we measured off the printer. They're 3.5 in diameter because we know they're M3, and they are to mount our mounting plate to the X carriage. And we know that if we do them 69 up from the nozzle, that the nozzle will sit, that the top of the E3D mount will sit exactly in this location here. Now if you're using a different hot end and a different nozzle arrangement, you can change those numbers and you can design it all in that way, but this is what it turned out for me. So if we stop that sketch and hide it, you'll find that all I did was I just used the hole geometry to cut some holes in. And then of course I wanted the holes to be recessed, so I literally just on the center of those holes I just drew bigger circles and extruded those in, but I only extruded those in a little way so that the heads of the screws would be behind the top surface. I'm using my hands too much and not pointing at the screen, I'm sorry. But yeah, we want the heads of the bolts to be behind that surface so they don't foul anything with the extruder or the stepper motor when we put them in. So another sketch we did, what was this one? Ah, right, yeah. There's an arm on the extruder which allows you to preset the tension for the filament. Now that arm needs a little bit of clearance because it sticks out the back of the extruder. So what I did was I drew a rectangle and took some material away at this point. Switch that off. So we've now got a step here, and then I drew a circle and extruded the circle. Sorry, I extruded the material around the circle back out to build this curve. Now the way I did that, I'll just edit that sketch so you can see. The way I did that was, because it pivots around the top fixing point, I just put a huge circle in and then I set it to a 2mm distance underneath the top face so that we didn't have to mess about measuring kind of like radiuses and things. I just wanted to know I needed 2mm of clearance, and then I used that bit of geometry there to extrude this. Oops. And then I decided that I wanted the rest of it to be flat, so I literally sketched in a rectangle and extruded that rectangle, and it made kind of like a recessed pocket. There we go. And then we moved on to the E3D mount itself, and I just invented some hole positions for these mounting screws and extruded them in. So there's the mounting holes. And then if I turn it around, finally on this part, I sketched on a couple of hexes on the back and extruded in the holes. Now the trick to this is, because it won't print this, because we want this surface to be on the glass, it won't print this without, because it's flat without support. I then added a couple of fillets into this location to literally make it so that the holes could climb. What I'll do, I'll quickly just show that by cutting that back to there, and you can see now that this is angled, so that will actually print. And then I decided, let's just press some buttons here. Press the house, that's better. I then decided that I really wanted this recess to go right to the end, so I just used this piece of geometry and extruded it right off to the end like that, so it made it go all the way off the end. And that was pretty much the entire bracket. So what we'll do next is we'll move on to the other part of the clamp, and we'll show you how we built that and assembled it. So next what we do is we go to this menu option called Assemble and we hit the New Component button. And what that does is that allows us to create a new component within the first component so that we can then assemble things. It doesn't appear to do anything, it just creates this square, but you're now drawing on a whole new set of sketches. So first of all, I started down here and I literally created just a rectangle. The rectangle was the distance from here to here, minus 1 millimeter for clearance, and it was long enough to span between the two fixing holes. And then I created another sketch and revolved into the back of it exactly the same profile that I revolved into the other part for the E3D mount. So, losing control of the screen here. So that will now match this, and this now match together. It's pretty easy to do because you can just use the dimensions off the other part. And then there was a sketch and an extrude just for a couple of holes, and you just want to make sure that the dimensions of those holes are in the center of your block and they match this this block here. Let's just let's turn it around. That's it. And finally I added another extrude which just chopped this corner out, because as you can see here we've got a little bit of a problem where we need to put a corner in. Now I always like to put 0.5 millimeter of space to 1 millimeter of space in here, because during the printing process things will change size slightly. So that's what that little knockout for is there. And finally, using the assemble joint command up here, I added a joint between the fixing hole and the fixing hole just to see if everything lined up, and as you can see those holes line up, and if we look at the mount we can see everything lines up in those locations. So basically, in a nutshell, that is how I came up with the design. Now as you're designing this thing you may discover that your initial dimension is too big down the bottom, so you have to go back to the initial sketch, which is all the way back here, and change the dimension. It ended up at 62. I think it started off about 70 or something on this one, and everything will update and rebuild the model as you go, so you can see what your changes are doing. I also believe these fixing holes started off further up and I moved them down just in case I wanted to put the volcano mod onto the E3D hot end at some point. But that is it. That is how the design process worked for this part. I didn't measure anything. I didn't have anything planned out in my mind for the design. I just kind of like started throwing sketches and extrusions at the screen and saw how it came about. There are two things wrong with this mount. The first thing is it's pretty small, and it's got square corners which don't print out very well, so you have to print it with a brim. It would have been better if it was rounded corners, but I don't see a way to round this corner and make it look good, or this corner and make it look good. And I didn't really want to make it any bigger to add rounded corners to it. And the second problem with it is the fact that there's no provisions to put a layer cooling fan on it. So that might have to be something I'll have to revisit and add some geometry to here so that I can put some screws in and mount a fan bracket to it. Or I may just go back and completely redesign the entire thing with a fan bracket in there. But anyway, that's for the future. This is the design we're going with for now for this extruder. So what you do at this point is you press the make button and it'll say, okay, you want to make this. And I don't like to send things directly to rPETg, I just like to output them as STLs. So I untick the Send to 3D Print utility, and just, you can see we've got two components here. So you just click one, and it generates the mesh, you hit OK, and it saves the file. You do that to the other one, and that's it. You've got your files. You can go ahead and load them into your slicer, slice them, and print them out. I printed both parts out, and it took about an hour and a half, 0.2 layer height, 60 millimeters a second. It didn't take very long at all. And what we'll do is we'll go over to the workbench and I'll show you how it turned out and how we assemble this stuff. So here we are at the workbench, and what I'm going to do is I'm going to start off by building the Mark8 extruder. This is an all metal left extruder. This is the base, and like I said in the card, this is 4 thick. And the distance from here to the centre of this hole was 6.5. That was all measured before we started the design. So a lot of people look at these and they think, good God, there's a lot of parts to this, what do I do? Take this small screw, screw it into the small hole here. It's a bit fiddly. You may well need a screwdriver to do this first time, because it is quite annoying. And what you want to do is you want to screw it half in. Like that, that's absolutely fine. Then we take the arm and we take this bearing with a groove in, and we take the large flat-headed screw and we screw that into there. What you do is drop that on the floor, because everything in here goes on the floor eventually. So we'll try screwing that in. Screw that into there again. That's it. Now that will turn, and you'll notice that the screw doesn't actually come out the back, so you can screw that in quite tight because it's a bearing, and that will still turn and that won't come out the back. Right, so that's that bit. Then what we do is we take this, which is a socket cap head, and we screw it into the top hole here. Now this is your tension adjustment, so what we'll do at this point is we'll just screw it in so that it's not coming out of there. That's fine. And finally we take this spring and this large cap headed screw and just push it in the top. That just stays like that, and then this, which is the little aluminium spacer, just drops in the front of there like that. Now that is all the assembly you need to do. So this is our printer, and this is not going to be the easiest thing to do in the world. This is the printed bracket. As you can see, it looks exactly the same as it did on the card. There's the hex holes in the back, and I've already sunk 2 nuts in there. You might want to heat them up with a soldering iron and kind of like melt them in place, but they should be okay. And that's the bracket, and the other part of the clamp is this piece, and you can see there's the little notch, and the little notch fits perfectly, whoops, into that little hole there. There we go. So what we're going to do is we're going to use these two holes to mount it to the printer here. This is not going to be easy to film because I'm going to be standing in the way of the camera, so I'll probably end up fast forwarding this, but we'll see how it goes. One thing to state is we need 2 M3 by 16. These are socket pan heads. Now if I can get the camera to focus on this, you should be able to see that they are very shallow headed screws. Now that's important for these recesses, but I'll put them in and we'll see what it looks like. Sorry, I'm going to stand in the way of the footage quite a lot here. So what we do is we put, if we can, that screw in that hole, and as you can see it sits in quite nicely. Now we'll do the same for this one, if it will go in. There we go. There we go, and we just screw it in. These 2 screw holes, I'll zoom that in. These 2 screw holes already have nuts in from the back, so we literally just need to offer this up, line it up, using the right Allen key, just tighten them up. So that's what it looks like on the X-Carriage. Now you need to take your E3D hot end. This is a light 6, and as you can see I've already wired it into the harness. So just to recap, you need to connect the fan, the heater and the thermistor. This is a cartridge type thermistor. It's got a connector on, so I wired that in, and the fan also has a connector on just in case I want to swap it out. So this literally just sits straight in here. On the mount. Now you'll notice the Bowden tube is sticking out quite a long way. That was a trial and error. When you assemble it, you'll need to work out what your distance is between here and the hob bolt, because you want the filament path to be managed as much as you can. So then we take this section with the cutout at the top and we just push that on, and then we take 2 M3 by 30 bolts, that's these, they've got a washer on them, and we just go straight in. So that's what that looks like, and I always try and get the heater block to be in line with that, and the fan shroud will move. So the final stage is it all comes together. So what we need is we need this piece of the extruder, and you drop it like that, and then you take your stepper motor, mount this to it. It might take a few minutes to get the position right, but I always have the plug of the stepper motor coming up, or the wires coming out the top. And you need two M3x25s, which is this, and they go in the bottom, and they go through the bracket and into the motor. Whoops. I tighten these up till they're slack. Tighten them up till they're slack? Yeah, I suppose that makes sense. That's it. So they're slack. And now what you want is you want the arm, and you want the original bolt that came with the extruder to go in this hole so it sits flush. That goes in the top corner, and then you tighten that in. You might want to give the motor a jiggle before you tighten everything up. Now you can tighten this one quite tight because it doesn't affect the movement of the arm, and then we'll just go and tighten up the other two. You'll notice I haven't put a screw in this corner. I didn't see the necessary for it. So finally you take your spring and you put the bottom of the spring over that screw and push it into place till it lines up with this, and then screw this in till it barely catches, and then when you press that down you're now spring loaded. And if I zoom out a little, that is what the finished thing looks like. Don't forget to reconnect the wiring, of course. And that's it. It's ready to roll. The hardest thing is doing the wiring, in my opinion, but just make sure that that is just compressing the spring, because you don't want it to be too tight. And that's it. So what we'll do now is we'll do a test print and we'll see what it's like. So that was the print, and here it is. So I'll do the usual, try and show you as many different angles of it as I can, so you can see what kind of quality this printer's putting out now. This layer, when it started doing this section, the layer time was quite short, so it started to lose integrity on the corners, started to round them off. The top layer, I don't know if you can see, but the layer that was in touch with the glass looks really nice. The circle turned out really nice. There's nothing on this print that fitting a layer fan wouldn't solve. It would fix everything, you know, but we haven't got that on that bracket. There's a couple of things I need to say. First of all, if you're going to do this to your printer, you need to do something with your Z end stop, because the E3D is longer in the Z. So if you would just bolt this on and home your printer, you're going to smash it into the glass or whatever bed you're using. So you do need to do something with the Z end stop. And like I say, this is just a guide on how I designed and created a bracket and how I modified a printer. This is not the definitive, you must do it like this, and the usual disclaimer, you know, if you do this and break your printer, it's not my fault. Yeah, design your own bracket, make your own bracket, and modify your own printer. It's all at your own risk. But to me, this is exactly what a 3D printer's for. You know, you should be definitely looking into using 3D CAD and designing your own stuff and learning about how it affects and how you can make it print. The bracket, I'll put a link to the Thingiverse download page in the description, and this filament guide, I got that from Thingiverse, so I'll put a link to that in the description too in case you want it for anything. But yeah, if you've got any comments or any questions about the build process, the design process, let us know in the comments. And if you want to see more videos like this where I create stuff and bolt it to a printer, you know, let us know. It's always interesting to see what people want to watch and what they want to learn about. But that's it for now. So as usual, please like, comment, subscribe. I've been Steve. Thanks for listening.